Hello and welcome everyone. So this is Open Technical Forum for Trusted Firmware M project. And today on behalf of TFM, my name is Anton Komlev, I'm a tech leader of the project. And on behalf of trustedfirmware.org, I'm hosting this meeting. Today we have two topics to present and to discuss. First one was proposed by Ken. And this is the design review for PSA level 3 isolation. And the following this with the secure function models. This is alternative to the current library and IPC model. The Andrew will talk about it. So and let's discuss and give a feedback to the design. So let's start from isolation. Ken, would you like to take?
Okay, so let me share my screen. So can you see my screen?
Yep.
Okay. This is I'm trying to make it very short. So I have sent a mail to the mailing list to broadcast the design document for the isolation level 3 and call for reviews. So if you have some very detailed discussion, you can put the comments on there and or reply to that mail thread. So the content will be simple. We got three items here. First is isolation rules and the level 3, and then the MPU regions. Some partner may like to take a look at this part, and then the implementation dependencies, something like that. So for the isolation level 3, it's introduced in their sorry, the echoes, and it's introduced in their PSA firmware framework specification. So we're on the basic. Sorry, why there's nothing? Okay, sorry, I forgot to move the animation.
No, it's
So,
fine.
yeah. So basically, it means there are isolation boundaries between the secure non-secure side and between the secure partitions. Yeah, and here one thing we may need to focus is that we got a PSA root service here. In the specification, it describes that if PSA root service can be accessed by the other application root service or by the non-NSP part, it needs to be implemented in a secure partition. Otherwise, it can be a implementation defined mechanism. So here, I took one example here. The PSA root service in the upper side, so it may be accessed by the application root services or by the NSP. So it is implemented in a secure partition, and then another PSA root service would be accessed by the by other PSA root service only. So it is implemented in the SPM. In the SPM part, okay, sorry, it has to be put in the same domain with SPM. Now we are, in general, in TFM, we implemented them as a surprise core or something. So here in these slides, we will not introduce the isolation boundaries happening between the secure and the non-secure side because it relies on some fundamental framework like trust zone and multiple core, which has been introduced at the very beginning of the TFM design. And the mechanism needed some necessary supporting hardware, for example, SAU, IDU, and PC, for example. Yeah. So here we jump to the isolation rules and the level 3. I draw some diagram and blocks to describe that. So first, the rulers from I1 to I3 are mandatory. So for example, the I1 is the only code is executable, and I2 is the only private that is writable. I3 is private that is protected from the parameter prevented domain, which means that in the definition of isolation level 3, it says that the NSP do not need protection from other domains, and the secure partition needs protection from other secure partitions. And the PSA root domain needs protection from all other domains. So here you can see that if a secure partition want to access their private data or another secure partition, then it is not allowed. Yeah, that's the rule I3 means, and for I4 it becomes more stricter. So their code and read-only date over partition is prevented from their is protected from their other secure partition. But since the secure partition will not does not need protect from the PSA domain, so the PSA domain components like SPM or other PSA services still could access their read-only and the code from a secure partition. And I5 becomes even more stricter, so the code can be executed from any other domain, which means that the code belongs to a secure partition even cannot be executed by the SPM or the PSA service. The execute here means direct jump. Yeah, because the direct jump won't change their execution permissions or something. So we should prevent that. And I6 is the most restricted item rule. That everything is protected. Only SPM is an exception because SPM may need to access the private data over partition and to help to copy data from the client to their service. Yeah. So so that's the rules and isolation level 3. This page shows the combination between the rules and the isolation levels definition. So then we jump to the practical implementation in the TFM. So it use the MPU to isolate the memory regions inside TFM. So the imaging layout actually matters because it would decide the region number we would use, and also would mitigate the runtime initialization loop during the booting time. Yeah. So here I list some possible MPU region attributes. Some now in the V, especially in the V8M. So the privileged read-only and all the privileged level read-only, the privileged rewrite or all privileged level rewrite, and execution never, and privileged execution never is a V8 0.1 feature. So I think this table is the key point of this slide. So here listed the memory states. We need to set a MPU region attribute V's. And here are the rules on the different rules, what kind of the attribute we would need to be assigned to the MPU region. So for the mandatory rules, I want to ask 3, because they are in the last page, we put the a code from every components together, and so do the read-only dates. So here with the code and read-only data, we could just use one MPU region for that because they are continuous and with different attributes. There's a execution neighbor attribute being assigned for their read-only date because it is a date, not a code. And so does the read-write date. And because SPM and payload service are in the same domain, so they can share their MPU region. So because they are only at this same at one time, only one partition can be running. So we only care about the regions for the active partition. The inactive partition we do not need to care about it that much because they won't be executing. So there's a SPR tier in TFM to provide some fundamental shared runtime APIs for the partitions, and the partition may have some peripheral registers being memory mapped for accessing. So if one partition do not have any peripheral devices, the minimum number for the implementation to comply the rule I1 to S3 is 5. So we need, at least we need 5 regions. If we need to do peripheral, then each peripheral memory map registers needs one more region. So to comply the rule I4, some part is changed. So the SPM and payload belong to same domain, so they can share one region. And SPITR, because their SPITR maybe not, and the active partition maybe they may be not neighbors, so they are not continuous, so they may need separate regions. And the rest thing are the same. With this change, we at least need 8 regions to comply I4 and to comply I5. So still almost the same. One to mention here is that in I5, the even SPM could not execute the non-privileged code. So here we need to set the privileged execution neighbor to the unprivileged code. So at least for I5 and I6 may need the V8.1 feature. So I6 is still similar. The point is that SPM is an exception for the accessing. So SPM has the privileged read-only now. It has a dedicated region and it is running under the privileged mode. And the payload service needs to be run in another mode. So which means that the payload service, which is not implemented as a partition, may need some other mechanism to implement. So here list the combination of the region attributes, and the file, the minimum number is still 8 without any peripheral. If we need a peripheral, then we need to add plus more regions for the peripherals. So that's the table. And the last page is that the implementation dependencies. So the isolation level 3 implementation rely on the here isolation interface merge. After the here isolation interfaces are implemented, the detail, the practical hardware setting and the MPU switching is mostly happening in the here interfaces. And there may be the secure peripheral sharing between partitions are not permitted. So dynamic setting of the peripheral protection components may be necessary. For example, if there is a hardware component, there's a peripheral, it is accessed not by the memory mapped registers. So then we need to be careful because then we need to be careful, and then we may need to set the corresponding peripheral protection components to make sure it is not shared between the secure partitions. So yeah, that's a hint here. So I think that's all. I'm trying to make it very simple. I just focus on the core part. So that's all it, I think. And here
Thanks, Ken.
and it says focus on the SP the isolation happening inside the SPE. Yeah, because the isolation between the SP and ASP are also already introduced at the beginning of the project, I think. Okay, that's all.
Thank you, Ken. It's very, very interesting. Any questions? So simple.
Great presentation.
Yeah. Ken, you consider for dynamic switching the MPU regions, right, on the fly. And just assuming if we have more regions than the minimum, do you plan to utilize it somehow for static mapping or something?
Okay, that's not showing in this table. Actually, for example, let's take the I1283 implementation. I think only their active partition read-write need to be updated dynamically, which means that the upper the three regions above is just defined statically. They don't need to be changed dynamically, I think.
Yeah, but there would be problems in the state management of the device. For example, if another partition was using the device and it was doing something in between, and then it got preempted, and if another partition comes along and gets scheduled to use the device, it wouldn't know the previous state of the previous partition. So either it would have to reinitialize and trash all of the device state, reset the device again for reuse, or which might be problematic because when you return back to the previous partition, it wouldn't know that the switch had happened. So I would think that if we have to share peripherals between partitions, we would have to wrap this peripheral in another partition code, and the partitions would have to make call to this dependent partition. So there would be a sole owner for a device, and other partitions would need to make calls to this partition to use the device.
I think the secure peripheral sharing between partitions are not permitted, not allowed.
It's a problem today, Sobi, even if you don't use isolation, because if two partitions can be executed they're scheduled they're independently scheduled, then giving them both access to the same peripheral means you need some way of serializing access and knowing which partition is using it.
Yeah.
Which is partly what drives the desire to not have synchronization primitives as partition APIs, because shared data in concurrent systems is a big source of errors. So the idea is that if you've got a peripheral and you need two partitions to use it, then there should be a service that basically mediates access to it.
Yeah, that's what I was saying. Basically, you need a service which owns the partition and owns the device, and then any other service which needs to make use of the device has to go through this owning service.
Yeah. So I think so it's the active partition read-write mapping plus any partition peripherals that would need to be switched.
Yeah.
Ken, a question on the SPRTL read-write. Would that need read-write permissions when actually mapped into the partition, or does that only need read-only permission?
Sorry to mention this part. We don't need the read-write permission. We just need a read-write. Read-only. The read-write here is because there's there are some global maybe put into the maybe marked up by their compiler or the linker as read write, but it is mapped in the MPU as read only, so the SPITR never have a chance to change that. The one who can change the variable is the SPM. So SPM maybe need to
So
map
essentially, so that section is mapped is mapped into a partition as read only.
Yes,
And it's mapped in when you're running the but when you're in privileged state and you need to access it, the mapping might be switched to read write, privileged read write.
Yeah.
So so the box in the table is not necessarily what the MPU permissions would be. Or you need a footnote to explain that the permissions for the SPA RTL RW row is special.
Yeah. Yeah, it's special, I think. Yeah.
So I have a doubt on that in the slide. So when we do implement I5, rule I5 and I6, we are saying that we would need PXN capability to prevent SPM from accessing active partition code. Can we do it with the regular XN? XN attribute? Is PXN absolutely essential?
Well, without PXN, that's like the active partition code can't be XN. So then when it does so if it does an SVC, or you take an interrupt and you're now running in SPM state,
right.
Then it's possible to still execute that without PXN.
Yeah.
And
okay, there is a question from Michelle. Can you take a look on the chat window?
Yeah, in this proposal, the background region of MPU allowing all access is unused for sure. Correct?
Can you unmute if you are saying something?
Oh. You can't hear me?
Yeah, I can hear Michelle, but
Yeah,
Ken is unmute. If Ken is answering. Yeah.
That's not good. Ken's still muted.
Yeah, I can unmute him, but he's...
Yeah, it's not clear whether the background region is used as part of this MPU combination. Because it's a good optimization.
Yeah. I think, Michelle, maybe Ken has some problem on his side. Could you ask this question to the mailing list, and Ken will reply you?
Okay, and I got another question. So it's a kind of minimize the number of regions, because in some cases we may need some description of cacheable and uncacheable attribute for certain area. So maybe 8 is an optimist way of thinking the number of regions that is rarely needed.
Yeah, maybe.
Well, an 8 is without peripherals. If you haven't got peripherals, then, but of course you might want some of your privileged mappings if you've got peripherals that your SPM interacts with, so they're mapped as privileged read-write device memory. Then that would need regions.
For instance, if you have a peripheral like the flash access, you may want to have that area uncacheable, and you need as well to have access to the peripheral driver itself, which also will be uncacheable. So it means at the end, for doing the flash access, you may need 2 regions.
Indeed. I don't think Ken was looking at other regions you might need just for the device to be functional. So the all read only for your code, for the code is assuming that all code is in the same kind of memory, and that's, as you say, it's not necessarily the case. I think the challenge with the background regions is it fails to implement rules I1 and I2, because it means that because I1 and I2 are about only code is executable, not data. And so essentially it's the write not execute. If you can write it, you can't execute it. If you can execute it, it can't be written. And that should still be enforced in the privileged code and the privileged secure code, particularly, as a basic hygiene measure to prevent execution of data, Stack Overflow exploits. Because there is an execute never capability on even these M profile devices, that's why rules I1 and I2 are included as mandatory. There can be a relaxation in constrained environments for read-only and executable code, because often you get compile time constants embedded with the code. So we weren't, you know, we're not assuming execute only, but some constants are actually in the code and end up being not execute never. If we used a background region, what would that be? Can you actually specify the background region? You can't specify its access attributes, can you?
I don't think so.
You can just disable using it.
Every access is possible with the background in most of the platform, I think, from privilege access. So background somehow could be usable only for SPM, but it will not prevent access from SPM on other areas. So somehow it's it can maybe work for, as you said, for L1, 2, or 3, but later I don't think so. In other L4 possibly, L5 sure will not be able to use it, I think.
Yeah. I would propose to switch this discussion to the offline, because we might have not enough time for the second presentation, which I expected to be also very interesting. And by the way, Ken replied to you in the chat window, I think, and also read his answer. Okay, thank you. Can you stop your presentation to allow Andrew to share? Thank you. So the secure functions.
Yeah, let me see if I can.
Yeah, I tried to share your slides before to let people digest it and familiarize, but I was blocked by the site. It says you are sending too much. So big attachment not welcome.
Yeah, let me just. Oh, there we go. Finally, different applications trying to find where full screen mode is.
Yeah, I can see.
Okay, so this is a follow-up for the PSA FFM version 1.1, looking at providing sort of optimizations for implementation of the frameworks and secure services. So 6 weeks ago, it might be, that I presented what the overall roadmap with about 6 or 7 steps. And I've been working on updates to the crypto API, which has delayed this a little bit from getting presented. So this is step 2. This is not a major evolution from what was described before about how to switching from a sort of an IPC model where you wait for a signal and get the message, and moving it to a sort of callback based model within the secure partition. But this is a way of providing that kind of functionality within the framework rather than discarding the framework and using the library model. So here I've got some details of how we propose to implement it. Right, let's just see if I can, there we go. So a little context reminder, we have 2 programming models for developing and running security services in TFM. The IPC model, which is the one described also in the firmware framework, services are deployed in groups which are defined as secure partitions. partitions are programmed like a single thread C program. There's an entry point that doesn't actually return. That thread polls for service messages and other events and then can respond to them. Each partition has its own execution stack and context, and it's the secure partition that can decide of the signals that have arrived, which one to process next. So it can decide to prioritize services or interrupts as required. In contrast, the library model, which is in TFM, services are just functions that are invoked by the framework on the secure side. Each service function handles a request that comes from a corresponding client-side function. But the framework is in control of the execution context. So does it run on the same stack as every other service? And the sequence in which the handlers run. So if the framework would allow the non-secure client to send more than one request, then it's the framework that decides how to sequence the actual service handlers. And this is a model that applies to the entire system. So you either build TFM with library model and everything is a library is a function-based service, a secure function, or you build the IPC model and then you only get the PSA Affirmer Framework APIs. So in 1.1, we want to enable simpler frameworks that are either optimizing stepwise optimizations on the current IPC model, but the actual overall result would be that it would be possible to have a completely different framework implementation if the definition of all the services is simple enough. That requires most of the steps that we're going to have in the update. Today, we're just looking at sort of the secure functions, replacing the signals that come from services with a callback model. I think I've covered most of this before. The current IPC model is designed to provide flexibility for service developers that gives them the ability to do complex things potentially. But to allow that flexibility, the framework has to have a thread stack and execution context for each partition. If you've got high enough isolation level, then you have to run the secure partition in a different processor state, so there's more context switches involved. The entry point and main processing loop end up looking like boilerplate. If your services and your secure partition are quite simple, then that main loop processing signals is the same as the one you've got in every other one, just changing names for signals and service functions. So in a lot of services, that flexibility isn't actually used, and the costs to the developer and the implementation aren't actually benefiting anyone because they're not being used. But the challenge is that the library model is often too simple to use, or goes a little bit further than the developer would like, because it affects the whole system. There aren't any session-based APIs, which are the way the IPC model works. It doesn't have client identity. It doesn't scale easily to concurrent or isolated services, and it doesn't provide many mitigations against errors when processing the client parameters, because it just uses a pointer directly into the client memory. And if you want to move a service from working in one framework to the other, there's no easy route because they use completely different APIs. So there's a significant rewrite to make a service work in one and then the other model. So the proposal, it's not much change from a few weeks ago, but the details in the next few slides are more concrete. This is still an initial proposal, so it's open for review and feedback and update. I'll talk a bit more about just the plans of what to do with these proposals at the end. So what we're going to do is have a secure function model, which is an alternative programming model for secure partitions. So it's more like the IPC model and the library model, in the sense that it's a way of actually dealing with an individual secure partition. It's sort of a in-between world. So its services are implemented as secure functions, like the library model, and the framework invokes those functions when there is a request. Those functions are invoked whenever there's a connect, a call, or a close. We do still retain the client identity in those, and the client parameters are indirectly accessed using APIs, as in the IPC model. There is a further step in the roadmap to allow for direct access to optimize that. The framework invokes the secure functions directly when a request arrives, and so the framework provides the execution context. This may be a SAC that's a context specific to the secure partition, but it might be one shared by all secure partitions or by the SPM. There's not an entry point and signal handling loop anymore. There is an initialization entry point, but it's a temporary one and it's optional. The design allows there still to be more than one secure partition, similar to the IPC model. But a secure partition using the secure function model is still single threaded. So within one secure partition, secure functions run sequentially. They can't run nested or interleaved. But the framework is still permitted to run functions from different secure partitions concurrently. So it can interleave them or nest them. And this is a implementation defined property, just the same way it is for the IPC model in terms of secure partitions and concurrent execution. And we're aiming to have the API for the secure function model to be compatible with the IPC model API. So it's a break from the library model API. Let me stop for a minute. Are there any questions just in that overview?
Do I correctly understand you're planning to introduce the stateless version?
So yeah, there's another one of the steps in the roadmap is the ability for services to be stateless. So that'll be an attribute in the manifest, and a stateless service is one that doesn't get connection and disconnection requests. There's a sort of open question whether we would still allow connect and disconnect that gives a client the ability to send messages, or whether it'll be only a subset of the default handle services. So if a service has a default handle, which is one that doesn't require an explicit call to connect or close from the client, we might make stateless be an optional attribute of that sort of service, in which case there would be no connect and disconnect messages, and there would be no ability to independently identify sessions, because there aren't sessions anymore that are exposed to either the client or the service. So I've left it in here because that's sort of like it's an independent attribute option, because it's also something that could be useful for a number of IPC-based services today that aren't using the sessions and so there's no state that they maintain for a client. So merely just having the actual request messages arrive would have reduced the amount of switching between the SPM and the service, just to set up and take down connections.
Yeah, thank you, Andrew. Thank you.
Were there any other questions? Otherwise, I will carry on and talk a bit about how that appears in the secure partition manifest and how that looks. So we're going to add an attribute, which we're currently going to call model, to be to the secure partition, the top level, and the model has to either be IPC or SFN. Because at the manifest file level, you have to declare that this is a version 1.1 manifest file. So you define the PSA framework version in the manifest. So if you define the version to be 1.1, then you have to also define the model attribute, and it's either will be IPC, which gives you the current set of behaviors, or it defines it to be SFN. And if it's set to be SFN, then the following changes apply to the actual secure partition manifest. So with SFN, the entry point attribute is not allowed, and instead we have a different attribute, which is entry init, which is optional. If present, this is the name of a C function which is used to initialize a secure partition. The initialization function, we're going to allow it to return an error, If it returns an error, then that partition is effectively non-functional, and we'll leave it to the framework as an implementation defined behavior, whether that means it will stop running altogether, or whether it will just make, do some diagnostic on that issue, but run anyway. But if it returns success, then that indicates that the SPM should deliver secure function calls into the secure partition. Currently have a mandatory stack size and heap size attributes, which declare how much stack and heap memory that the secure partition requires. Because the secure function model doesn't require the framework to provide a dedicated context and stack for the secure partition, these become hints to the framework. So if the framework does implement them as independent entities, particularly isolation of level three, this will be required, then it's likely that then these will still be used as a stack size and a heap size. So you still need to define, have these attributes, but they might not be used in exactly the same way. They don't require the framework to allocate a specific stack for the secure partition. In the secure function model, there are no service signals anymore. So the signals that for services don't exist, they're not allocated, and the names for those service signals won't be defined in the header file that is generated by the tools. Instead of the signals, what happens with the services is that we end up defining a secure function with this prototype. So the secure function is sfn_service name, and that will take a pointer to a request message, which is the same as is found in the IPC model, and that function will return a status code. I'll talk a little bit more about the behavior of those functions on the next slide. One of the alternatives we considered was whether we should have an attribute that allows the developer to name the function within the service description, or whether we allow that as an override so that the default is that we have the sort of generated name, but we can override that with a developer specific name. If you've got any preference on that front, I'd be glad to hear it. At the moment, adding an override is quite easy to do as an extension or a later addition to this proposal. We're proposing at the moment that interrupt requests and the doorbell still work and are defined in the same way that they currently work. So they will use secure partition signals. There's a question about whether we would actually change that to using the same kind of callback model, but our internal discussions have that still in the air. So the reason an IRQ using a signal is useful is a secure function might initiate some hardware activity and then want to wait till the hardware the peripheral completes with an interrupt before returning to the client. So in that case, the secure function can use PSA wait, and it can actually check or poll, or it can block for the specific interrupt or for the doorbell signal before continuing execution. So that's how an interrupt in a partition can still interact with a secure function. Are there any questions on that, or comments on the names or the approach taken? Okay.
I think it needs time to digest and to think about it.
Yes. So this will be available on the. I'm pretty sure, and you entered it. You're going to try and get this.
Yeah. It will be available on trustedfirmware.org and the record as well as slides.
So how this affects writing secure functions as opposed to the current code where you have you're waiting for signals. So secure functions will still receive connect, disconnect, and request messages. Well, there's a footnote here I just said, but actually we'll be able to eliminate connection and disconnection as an option in the service. So the same that these are delivered to the secure partition in the IPC model. So once you have in a secure function, you get the request, you have a pointer to the request message. And with that, you can then use the PSA read, the PSA write, skip, which basically skips past some of the data in a read input parameter, and the set R handle functions. So you can associate service side resources with a particular session on the client. The return value from the secure function is the actual reply status for the message. So the PSA get and PSA reply functions don't work within a secure function model because the framework does the message retrieval and the message reply. PSA wait will still work as long as you've got IRQ signals or a doorbell that you want to wait for. There aren't any service signals, so you can't kind of like do nested waiting for more messages. Because messages are replied when a secure function returns, and a secure function, until a secure function returns, no other secure functions within that secure partition can run. This essentially guarantees that messages must be processed in sequence, and a message must be completed before the next message will get processed. So that's a constraint that the secure function model imposes on the service, which isn't present with the IPC model, but that's part of what the trade-off here is. So the rest of the APIs that we've got, whether it's the client APIs or the secure partition APIs, work the same way as in the IPC model. So a secure function can invoke a service that's in another secure partition by using PSA call, for example. Are there any questions about that? Otherwise I will just look at the last slide here. So as a sort of at a conceptual level, it's like we're thinking about, well, what does the implementation look like if you're doing this within an environment where you have some IPC model partitions and in a secure function model partition? So effectively, this is what the additional work that the framework is doing in a secure function partition, in a secure function model, when you have just one service. So if there's one service and the framework behaves as if this is what was happening in an IPC model entry point, that we're doing an infinite loop where we wait for just the service signal, and then if we can get a message for that service signal, we'll dispatch to the secure function service handler with the message, and we'll send that response to that as a reply to the original message. Obviously, this isn't exactly the code you would end up generating in a framework that's providing the secure function model, purely because service signal wouldn't be defined as a name in that respect. But it's a sort of an outline of how you could implement this inside a runtime library that is running in an isolated partition that's providing secure function model. But as this is underneath the hood, the implementation is free to find other ways to achieve this. So the example I have here is if you've got if you've got isolation level 1 and you have a single partition, then the SPM might invoke the secure function service directly after compiling the message from the parameters from the client. That's kind of the entirety of the update in here. I included the roadmap in an appendix, so that if you look at this slide later offline, you can find it. So the plans I've got here at the moment are to continue working on the roadmap steps. In the process of finalizing the proposal for step 3, which was actually memory mapping client parameters, and drafting up interrupt handling and stateless services. although we've got a more detailed write-up of these proposals internally, in order to publish them for wider review, what I'm planning to do is actually compile them into essentially a version 1.1 alpha update specification. So it won't be an update on the original, it'll be a separate document which describes all of the changes that we will make to end up with version 1.1. And that will be a document which has got a lot more of the detail included, which we hope to be able to share confidentially for partner feedback. And if I, I'd like to be able to share it non-confidentially, but I'll have to see whether I get approval for that at the moment. So happy to take questions now on the mailing list, or you can send them confidentially to us via the PSA feedback email that's here in the slides.
So the slides will be available for
Yep.
us to analyze?
Yes. So
Okay.
the last set of slides were, Anton did put them in the TFM technical forum.
Very good.
I've said to Anton, if for the next update that I have on this, I will prepare the material and actually get Anton and I will probably put it onto the mailing list a few days before the forum, so that it gives you more of a chance to have a look at the proposal and be ready with some feedback or some questions if that's appropriate during the forum.
Yeah, I think that would be the better approach with such difficult and kind of heavy materials. As I said, I'm already trying to share this in few hours before the forum, but yeah, it was blocked by the mailing list. So we will find another way how to share it in advance before the forum.
Does a mailing list not accept?
Mailing list accept maximum 80 kilobyte of body.
Right.
If somebody sent more, it requires a moderator to check it and allow.
I guess you could put it put it in the technical forum.
Yeah, that's
upload
what
it
I'm
there,
thinking.
and then we can provide a link to it.
Yeah, that's what I'm thinking. Yeah, probably that how it
Okay.
will end up.
So at the moment, I'm hoping I might actually be able to reach this alpha update specification just within a few weeks. But because I'd like to release it as an alpha for update for review, because that means that we'll happily entertain significant changes if the feedback just says that we need to make significant changes, rather than waiting till it's nearly a beta and then I'd rather have the feedback sooner so that we make sure we get it right, basically.
Any questions to Andrew? Well, questions are cooking. So let me ask: is it correct what I understand that both IPS and SFN allowed to present in the same system?
Yes.
So some partition will be SFN, some IPS.
Yes, at the level it's at this point, the SFN is a secure partition level option.
Mm-hmm.
Because it makes it easier it's easier for a developer to write a service as using SFN than IPC. If the feedback says, look, it's actually too complicated to make the system develop this to build the implementation like this, the framework, and it needs to be a system-wide switch, then we can either make it so, or we can make it possible for an implementation to require them to all the partitions to have the same model, rather than it being, if you're a compliant implementation, you have to support a hybrid.
Yeah, I think that would where the feedback would be very appreciated. I have a feeling like it could be too heavy to support hybrid.
I guess that's partly where it would, that in terms of developing the spec, I'm hoping for TFM's feedback in terms of okay, we were trying to build this as a sort of like an optional add-on when you've got an IPC model, and then we add the SFN model as well.
Mm-hmm.
But these are the things that get complicated. Like you actually implement it as I outlined here, with some generated code, except then you end up with some APIs that the partition has to be able to use for getting messages and replying to them and waiting for services, that although they're not necessarily in a header file for the services to call, they're still available for a service to get hold of because it's a supervisor call. And the supervisor call can't tell whether it's the framework code doing this or whether it's the the SPRTL or whether it's the actual SFN itself. And inject because this is cleaner than injecting calls into another context from privileged mode and injecting calls into unprivileged mode. And you might decide that actually you'd rather just have not mixed mode, because then it's easier to separate out the framework support from the secure functions. But I'd like to get feedback from some proof of concept work that looks at this before we kind of like we nail down all the details and declare it finished. So
yeah, right. The way I'm thinking is that APC and SFN is two different directions, and some system would like to have better protection and select IPC in the cost of performance. Some other system might need better performance and lightweight, so smaller footprint, and we'll go to SFN.
This particular aspect of the secure function of the whole update doesn't really reduce security, because you still have to deal with messages using the read-write APIs, and it still requires sort of like doesn't allow concurrent execution with the same secure partition, and partitions are meant to be logically sort of like modular. It's some of the other updates that basically may relax security a bit, and the most part of the relaxed security is if you decide to go for level 1 isolation with one secure partition, everything's a secure function, and you're using memory mapped client parameters, then it's a bit, you're running something that looks very much like library model, and yes, that is less secure, but you've deliberately chosen to make those trade-offs because you need it for your system, and someone has obviously signed off to say those are acceptable security trade-offs for this system. And so part of this is about giving the developer a wider set of tools, or a sort of a more of a spectrum of trade-offs between security, performance, and footprint. The challenge is partly going to be is at what points can the framework make significant optimizations, as opposed to just making life faster and easier for the developer, where the framework could make a radical sort of like change in its implementation because it reduces complexity.
Right.
So yeah, I mean, secure functions at the partition level is higher complexity than doing it at a system level. So I'm happy to have feedback on whether there are use cases that suggest we need to have the hybrid approach, or whether we push it out to being a sort of framework level switch.
Right. Let's listen to the feedback.
Yep.
We are just on time, perfectly, sharply. So I want to say thank you, Andrew. Very
You're
important
welcome.
and interesting. And looking for the feedback. Please provide feedback. This is real chance to affect on the specification. And thank you very much, and have a good day. I'm closing this.
Okay. Thank you, Anton.
Thank you. Goodbye.
Bye.
Thanks. Bye-bye.